National Electrical Code, or NEC, does not provide a specific definition of the term kitchen within Article 210.8b, which addresses ground fault circuit interrupter, or GFCI, protection in locations other than dwelling units. However, we can look to another section of the NEC, specifically 210.52c, for guidance. This section defines a kitchen as an area used for the preparation of food. Applying this definition, a countertop equipped with a microwave located in a lunchroom could potentially be classified as a kitchen, provided that it is used for food preparation. To accurately determine if a particular area qualifies as a kitchen, several factors must be carefully considered. Firstly, the type of food preparation taking place is relevant. Secondly, the frequency with which food preparation occurs is important. Thirdly, the equipment used for food preparation within the area should be taken into account. If the area is routinely used to prepare food and the equipment present is typical of a kitchen environment, then it is more likely to be classified as a kitchen. Consider the example of a countertop with a microwave in a lunchroom. If the microwave is regularly used for food preparation, the area might be considered a kitchen. However, if the microwave is only used occasionally for warming pre-packaged meals, it is less likely to meet the criteria of a kitchen. Ultimately, the final determination of whether an area is classified as a kitchen rests with the local electrical inspector. Their assessment will take into account the factors previously mentioned and the specific circumstances of the installation. When evaluating whether a space constitutes a kitchen for the purposes of NEC Article 210.8b, several aspects warrant careful consideration. Firstly, the primary function of the space should be assessed. Is the area primarily dedicated to food preparation activities, or does it serve a different purpose with incidental food preparation? Secondly, the extent and nature of the food preparation activities should be examined. Are meals being fully prepared from raw ingredients, or is the space mainly used for reheating pre-prepared foods? Thirdly, consider the presence and type of kitchen-specific appliances. Does the area contain appliances commonly found in kitchens, such as a cooktop, oven, sink with running water, or refrigerator? Fourthly, evaluate the availability of dedicated food preparation surfaces. Are there countertops or tables specifically designated and suitable for preparing food? Fifthly, the storage facilities available for food and related items are important. Is there adequate storage space for ingredients, cookware, and utensils? Sixthly, the presence of ventilation systems designed to remove cooking fumes and odors should be considered. Kitchens typically have range hoods or other ventilation to manage air quality. Seventhly, consider the plumbing infrastructure supporting food preparation activities. The presence of a sink with hot and cold running water and a drain is a strong indicator of a kitchen. Eighthly, assess the electrical infrastructure, specifically the number and placement of receptacles suitable for kitchen appliances. The presence of multiple conveniently located receptacles suggests a kitchen environment. Ninthly, review local building codes and regulations, as they may offer a definition of a kitchen or provide specific requirements for kitchen installations. Tenthly, consult with the local electrical inspector, as they have the final authority in interpreting and enforcing the NEC. Their guidance is crucial in ensuring compliance with the code. Regarding GFCI protection for 125-volt receptacles in kitchen areas of non-dwelling units, the NEC mandates such protection to enhance safety and prevent electrical shock hazards. GFCI devices are designed to detect ground faults, which occur when electrical current deviates from its intended path and flows through an unintended conductor, such as a person. When a ground fault is detected, the GFCI device quickly interrupts the circuit, cutting off the flow of electricity and minimizing the risk of electric shock. The specific requirements for GFCI protection can be found in NEC Article 210.8, which outlines the locations where GFCI protection is mandatory. For kitchens in non-dwelling units, all 125-volt, 15 and 20 amp receptacles serving countertop surfaces must be GFCI protected. This requirement applies to receptacles within 6 feet of a sink. The rationale behind this requirement is that kitchens are inherently damp environments due to the presence of water and plumbing fixtures. This increases the risk of electrical shock, making GFCI protection essential. In addition to countertop receptacles, other receptacles in kitchen areas may also require GFCI protection, depending on their location and intended use. For example, receptacles serving dishwashers, refrigerators, and other kitchen appliances may need GFCI protection based on the specific requirements outlined in the NEC. It is important to carefully review the applicable sections of the NEC to ensure compliance with all GFCI protection requirements. When installing GFCI receptacles, it is crucial to follow the manufacturer's instructions and to properly test the devices to ensure they are functioning correctly. GFCI receptacles should be tested regularly to verify their continued effectiveness. If a GFCI receptacle fails to trip when tested, it should be replaced immediately. The NEC also requires that GFCI protection be provided for certain appliances in kitchen areas, such as dishwashers and refrigerators. This can be achieved by installing GFCI receptacles or by using GFCI circuit breakers. GFCI circuit breakers provide GFCI protection for the entire circuit, while GFCI receptacles provide protection only at the point of use. The choice between GFCI receptacles and GFCI circuit breakers depends on the specific application and the overall design of the electrical system. It is important to consult with a qualified electrician to determine the most appropriate method of providing GFCI protection for kitchen appliances. Furthermore, it is essential to maintain accurate records of all GFCI installations, including the location of the devices, the dates of their installation, and any testing or maintenance performed. These records can be helpful in troubleshooting electrical problems and in demonstrating compliance with the NEC. In summary, defining a kitchen for NEC purposes requires careful consideration of several factors, including the type and frequency of food preparation, the equipment used, and the presence of kitchen-specific features. The local electrical inspector has the final authority in determining whether an area is classified as a kitchen. For kitchens and non-dwelling units, GFCI protection is mandatory for all 125-volt, 15 and 20 amp receptacles serving countertop surfaces, as well as other receptacles and appliances as required by the NEC. Proper installation, testing, and maintenance of GFCI devices are essential for ensuring electrical safety in kitchen environments. To further elaborate on the factors influencing the classification of a space as a kitchen, consider the following points. Firstly, the presence of a permanent cooking appliance, such as a range or cooktop, is a strong indicator of a kitchen. These appliances are specifically designed for cooking and are typically found in kitchens. Secondly, the availability of a sink with both hot and cold running water is another key factor. Sinks are essential for washing food, utensils, and cookware, and are a standard feature of kitchens. Thirdly, the presence of a refrigerator or other means of food preservation is indicative of a kitchen. Refrigerators are used to store perishable food items and are necessary for maintaining food safety. Fourthly, consider the availability of dedicated food storage areas such as cabinets, pantries, or shelves. These storage areas are used to store food items, cookware, and utensils, and are essential for organizing a kitchen. Fifthly, the presence of countertops or other work surfaces suitable for food preparation is an important factor. Countertops provide a stable and sanitary surface for preparing food. Sixthly, the availability of adequate lighting is crucial for safe and efficient food preparation. Kitchens typically have bright, well-distributed lighting to illuminate work surfaces and prevent accidents. Seventhly, the presence of ventilation to remove cooking fumes and odors is an important consideration. Range hoods or other ventilation systems help to maintain air quality in the kitchen. Eighthly, consider the overall layout and design of the space. Kitchens are typically designed to be functional and efficient, with appliances and work surfaces arranged in a logical manner. Ninthly, the presence of small appliances commonly used in kitchens, such as toasters, blenders, and coffee makers, can also be an indicator of a kitchen. Tenthly, the way the space is used by the occupants is an important factor. If the space is primarily used for food preparation and related activities, it is more likely to be classified as a kitchen. Remember that the local electrical inspector has the final authority in determining whether a space is classified as a kitchen for NEC purposes. Their decision will be based on a comprehensive assessment of all the relevant factors. It is always best to consult with the electrical inspector to ensure compliance with the NEC. To provide additional clarity on GFCI protection requirements, it is important to understand the different types of GFCI devices available. Firstly, GFCI receptacles are designed to replace standard receptacles and provide GFCI protection at the point of use. These receptacles have a test button and a reset button, allowing users to verify their functionality. Secondly, GFCI circuit breakers are designed to replace standard circuit breakers in the electrical panel and provide GFCI protection for the entire circuit. These breakers also have a test button and a reset button. Thirdly, portable GFCI devices are available for use with portable tools and equipment. These devices plug into a standard receptacle and provide GFCI protection for the uppercutter plugged into them. When selecting a GFCI device, it is important to choose one that is appropriate for the specific application. GFCI receptacles are typically used for receptacle serving countertops in kitchens and bathrooms, while GFCI circuit breakers are used for circuits serving entire areas or appliances. Portable GFCI devices are used for portable tools and equipment used in damp or wet locations. It is also important to ensure that the GFCI device is rated for the voltage and amperage of the circuit it is protecting. GFCI devices are typically rated for 120 volts or 240 volts and for 15 amps or 20 amps. Installing a GFCI device that is not properly rated for the circuit can be dangerous and can result in electrical shock or fire. When installing a GFCI receptacle, it is important to follow the manufacturer's instructions carefully. The receptacle should be wired correctly and should be properly grounded. After the receptacle is installed, it should be tested to ensure that it is functioning properly. To test a GFCI receptacle, press the test button. The receptacle should trip, cutting off power to the circuit. Then press the reset button to restore power to the circuit. If the receptacle does not trip when the test button is pressed, it is not functioning properly and should be replaced immediately. When installing a GFCI circuit breaker, it is important to follow the manufacturer's instructions carefully. The breaker should be installed in the correct location in the electrical panel and should be wired correctly. After the breaker is installed, it should be tested to ensure that it is functioning properly. To test a GFCI circuit breaker, press the test button. The breaker should trip, cutting off power to the circuit. Then reset the breaker to restore power to the circuit. If the breaker does not trip when the test button is pressed, it is not functioning properly and should be replaced immediately. Regular testing of GFCI devices is essential to ensure that they are functioning properly. GFCI devices should be tested at least once a month and after any electrical storms or power surges. If a GFCI device fails to trip when tested, it should be replaced immediately. In addition to testing GFCI devices, it is also important to inspect them regularly for any signs of damage. Look for cracks, discoloration, or other signs of wear and tear. If a GFCI device is damaged, it should be replaced immediately. It is also important to keep GFCI devices clean and free of debris. Dust, dirt, and other debris can interfere with the operation of the device. To clean a GFCI device, use a soft, damp cloth. Do not use any harsh chemicals or abrasives, as these can damage the device. By following these guidelines can ensure that GFCI devices are functioning properly and are providing the intended level of protection against electrical shock hazards. Remember that GFCI protection is an essential safety measure that can help to prevent serious injuries and fatalities.